Okay.
Over to you.
So,
Yeah.
so let me share my screen. My screen is visible?
Yeah, Hardik. Yeah,
Yes,
yeah.
visible. Okay. So, hello guys. Am I audible?
Yeah, Hardik. Yeah, yeah, yeah. You are
Yeah.
audible.
Guys, let's keep it interactive. And if you have any doubt or any question, just ask me. Just don't be shy about it. I will ask in the end. No. Just ask it. Okay. So this is our first class, first demo class. So in this class, we will learn about how we can design our PCBs and how we can do it with KiCad specifically. So so here is a quick intro about me. So my name is Hardik and I am an embedded engineer. I love electronics and playing with electronics from class 7. So I am into electronics. I am core electronics guy. So I have 3 years of experience in embedded system. So I work in a startup. So here we have to program as well as making hardware. So I know a little bit about firmware side also. And currently I'm working in Stempedia, where I am responsible for making new products. So we design PCBs and usually we write firmware in MicroPython. So let's start. So what is PCB designing? So do you have any idea and what are your views on it? Anyone from the chat? Hello. Hello. Am I audible?
Yes, you are audible. I think anyone in chat, just tell me if you have the basic idea of the PCB. Yeah, like any idea about the PCB. Yeah, you don't know about the PCB. Okay.
Yeah. So any one of you have seen these type of boards ever in life? Like this type of board. Let me open a cursor flow. Yeah, this type. And now I hope my mouse pointer is clear to you. It is in blue circle. So we all see these type of boards in our daily life, like as mentioned in the PPT. So this is OnePlus Nord 2 phone, and here we have this black color PCB on which we have our camera and some pins for the power button. Like here we can see more about it. So here we have front camera and here we have thermal paste. These are volume rockers button pins, and here we have our camera. So this is our PCB of OnePlus Nord 2. So we all are surrounded by these PCBs and these electronics. So these PCBs are basically backbone of our all electronics, and every electronics which we see in consumer goods. So so now the question arises why it is important. So do you have any idea why it is important and what's the difference between breadboard and PCB? Guys, anyone from the chat can any rough idea?
Uh, Reduce wires, hardware wires. So in
Yes.
breadboard, it will look like a bulky.
Yes.
That is the main
Yes, sir.
important.
Yeah. Absolutely. That's a right reason. That's a correct answer. So when we see these types of when we usually make circuits, let me show you a picture of it. So basically, what happens when we make our circuit in breadboard? So usually, what happens is it is very complex and it is very hectic to look. And if we have to replicate that circuit, like if we are making a phone or some consumer product, so we have to put those wires again and again. And as you know, breadboard wires are very shaky, and sometimes a wire just removes and our circuit stops working. So breadboard is good for prototyping, but for scaling electronics, we need a printed circuit board. Are you getting my point?
Yeah.
Yeah, so let me show you a picture of it. Yeah. So if we make a PCB, like initially we used to make PCB like this. So there are a lot of wires and very hectic and very messy. So then we have some advancement, and we landed on these PCBs like this one. So with the help of PCB, we can just print these physical wires on the board itself. So like here we have just a prototype example. This they have make on puff board. Here they have connected a header pin, and here we have some bunch of resistor and a wire. So so this thing is very some time taking and consuming process. But if you make a simple PCB of it, then we just have to place resistors and solder them. So it is very easy for electronics to it is very easy for us to scale electronics with the help of PCB. Okay, so let's jump back to our PPT. So this is a simple demonstration I give it here. It's like here we have our simple Arduino circuit. Here we have a LoRaWAN. This is the transmitter module, and this is the receiver. So we simply, after our prototype is tested and our circuit is tested and our program is tested, now we can make a custom PCB of it, just like on the right side you can see. And we can fix these circuits, and we just have to solder those components, and we are good to go. So that's why PCBs are important. So PCB helps us to scale electronics. Yeah. So next part is PCB designing tools. So what happened is we design these circuits with the help of some computer CAD software. So CAD software helps us to make these printed circuit board and give us a manufacturing file, which we send it to our manufacturer, PCB manufacturer, and they will manufacture for us, and we get the PCB. So there are various tools available for the PCB designing. So first one is Altium. Have you heard of it? Altium Designer. Anyone from?
Yeah, it is a standard
Yeah.
tool. Nowadays, companies are looking for Altium users. KiCad is the basic. College students every will do EasyEDA and all. But nowadays, industry, according to industry standards, using right.
Yeah, totally agree with you. Totally agree with you. Mostly industries, even in my company, I use Altium. But the thing is, for learning purpose and for starting with PCB designing, KiCad is good to go, because I tell you a reason. Because the thing is, Altium is paid software. So if you have to pay some 4-5 lakhs for a tool just to learn it, it is very hectic for a student. Does it make sense? Hello.
Yes. He can't able to pay because he's on the he's in college.
That's why we have chosen this KiCad platform, as it is open source and freely anyone can use KiCad. And another good thing about KiCad is it works on multiple OSs. Like I'm using Mac. It is working on Mac, and you can also use it in Linux distro, or you can use it in Windows. So it is having cross compatible. So another good thing about KiCad is that it is cross compatible, and EasyEDA is also very good, but but in my personal opinion, I like KiCad because KiCad is having good UI and good features. And another advanced software is just like Altium. Some companies use Cadence. So Cadence is similar to Altium. Okay. So guys, do you have any doubt? Any questions?
See, industries, why not using KiCad? Why will go Altium? I mean, Altium is more specific, some tools, advanced tools. Is
Yes.
it right?
Yeah. So very good question. Let me the thing is, let me tell you the answer. The thing is, KiCad is good to go for PCBs. There is no problem. But as I told you, when especially we are making a consumer product, so what happened with consumer product is we need some casing. Like if you are designing a if you're designing a PCB of, let's suppose, if we're designing a PCB of our earphone, that wireless earphone, right?
Mm-hmm.
So we have we just can't make the PCB of it. We have to make a physical structure, physical plastic, physical model of it.
Mm-hmm.
Are you getting my point? So all
Yeah.
those options are missing in KiCad. So you can't place mechanical structures on KiCad, but we can do it in Altium. So let me show you an image of it. Altium 3D body. Mhm. Yeah, like this one. So you can see this is a physical PCB, and on this yellow section we have this mechanical body. So it gave us good overview about the overall product.
Okay, okay.
Yeah. So all these features are missing in KiCad. So that's why generally you can prototype any circuit or any layers of PCB in KiCad, but for it's good for prototyping purpose, but for scalable product, for consumer product, we need we need some physical body which is missing. So any other question?
Nothing. You can continue.
Yeah, I hope I answered your question, right?
Right.
Okay.
Thank you.
Yeah. So here is our PCB designing workflow. These are the steps we generally follow to make a PCB. Either we are making in Altium or either we are making in KiCad. So this is the general flow diagram of it. So first is schematic design. We design our schematic. So do you have any idea about schematic design? Let anyone from the chat?
Schematic is nothing but so based on the schematic, we have to go to the Gerber files and next process. Without
Yeah.
schematic, we can't able to do, right?
Yeah, agree. So, PCB schematic is basically a simple circuit diagram. Simple, in simple words, we can say it's a simple circuit diagram we draw. So, as you can see here, let me open a simple circuit diagram. Let's see here we have. So, guys, my screen is visual, right?
Yeah.
Yeah. So this is a simple circuit diagram. Here we have a capacitor. Here we have some Smith trigger and resistor. And this is our LED. So this is the simple circuit diagram. So before making PCBs, we have to make a schematic. So we have to tell our PCB designing software like how we are connecting resistors and how we are connecting LEDs and how we are connecting it to MCU and all. So we have to make these type of schematics firstly, and now second part is component footprint. So like you can see in this circuit, now we have to tell our software what is the size component footprint is nothing. We have to tell our software like what is the size of that particular component, right? So we have to tell what's the size of this capacitor. We have to tell what's the size of this resistor. What's the size of this resistor? What's the R2 resistor? What's the size of this LED? Are you getting my point? Let me show you a footprint images. PCB.
So my question is,
Yes.
if a PCB design engineer, he only design from end to end, or else he only do based upon schematic he will design, or else he only write a circuit diagram, or he only do like that.
Sorry, I don't.
What is
understand.
main role?
I don't understand. So, can you repeat it?
Okay, sorry. A
Yeah.
PCB design engineer, he will do only based upon schematic do design, or else he will make own his circuit diagram, or else he will do from scratch. I
Yeah.
think you understand, right?
Yeah. So the thing is, sometimes the answer is you can do both. We generally do both. Sometimes we know the circuit. Sometimes we are using some different new ICs. Like if we are using some INMP mic. Just few days back, I'm using a new mic. So I have to go into data sheet. Generally, what happens is they have a reference diagram of it.
Mm-hmm.
So generally we copy it from there. Like there is some manufacturer recommendation, like you have to use this number of capacitor on this pin, and this is the voltage rating and all. So this is mentioned in the data sheet. Let me show you example of it. Let's suppose. Do you have any example IC? I will show it to you.
Any example is no, you can use your own.
Okay, let's suppose I think we all are familiar with ESP32, right?
Yes, with it. Okay.
Yeah, let's open a ESP32 data sheet. And here we have hardware recommendation. Wait a minute, hardware. So we have this ESP32 hardware design guidelines. So here we have a link. We have schematic checklist. So this is the general they are recommending. This is the general circuit they are recommending, that you have to use this MCU in this fashion. Like if you have VDA, you have to connect 0.1 mu F capacitor there, and like if you have on 47 pin, you have to connect a capacitor C6 of rating 3.3 NF. These are the general recommendations by the manufacturer itself, like how we can use this IC. So generally we copy it from there. I hope I answer your question, right?
Yeah. Hardik, thank you.
So all this you can see. Generally, we found all this in the hardware design guidelines. Like here we have ESP hardware design guidelines. So generally, we all manufacturers of particular chip and all are recommending some checklist. So we have to follow those. So let's continue. Yeah. So I will show you a footprint images. Yeah. So here is the footprint image. So can you see that golden pads? This green color is our PCB, and all those golden area is our footprint. Are you able to see?
Yeah, it's looking. It's
Yeah. So we have different type of footprints there. Like here we have dip. So these are different type of sizes of components. So generally you can see we have a through hole component. Like we have surface mounted component. We have through hole LEDs. We have surface mounted LEDs. So we have different type of shapes available. So we have to tell. So here we in the second we have to tell our software that which component we are using. So the third is routing and board layout. So routing is let me show you an image of routing. So routing are all those traces we see like here. Routing are all those traces we can see on those PCBs and how we are connecting our ICs to one another. So let me show an image of it. PCB routing. Yeah. So these green and red traces you can see, these are routing. Let me open it. So these are routed nets. Okay. So so firstly we make the schematic, then we assign some components footprint, then we route those components, basically connecting those components with each other, and then another part is board layout. So board layout is the physical shape of our PCB. Like we want to design it in circle, we want to design it in rectangle, like the physical shape. So then we have to assign some shape to that PCB. So after that, so our schematic is complete, footprint is done, routing is done, shape is done. Then we send our PCB Gerber file to the production. So Gerber file is similar to, how many of you use 3D printers? Anyone? Okay, no issues. So so it is similar to the manufacturing file which we have to send to our manufacturing partner for the production of that PCB. It is similar. You can say, I guess many of you guys are from software domain, so you can. This is similar to the bin file. In production, we are not using ELF file, evaluation file. We are not using. We are using that bin file. So this is similar to the bin file. We have to send it to the manufacturer for the production. So after this fourth process, our fifth process is assembly. So assembly is physically placing those particular component, right? We have used LED, we have used MOSFET, or any other active passive components, and we have to physically solder them. So this is the fifth part. So after this, our PCB is completed. So any questions in this PCB designing workflow? Any question in this?
So this Shiva, for example, if we have no component in the software, right? So can we create our component design, right?
Yeah. That particular component design, like you make something custom, right?
Yeah.
Sorry, your voice is not clear. Can you repeat it again?
So if we need any component, new component, so in the software, the component is not available. So according to the component design, we can design our own, right?
Yeah. So generally what happens is you can design your own components there. And another what we generally do is we have various websites available. Like I can show it to you. Like we have a website known as EasyEDA. Sorry, Snap EDA. So what this does is it provides almost every component's footprints and symbol. Like you can just type your component name here. Let's suppose if I type ESP32 here, if it is not in library, you can search it here and download the library of it from here. Like here I search ESP32,
Okay.
and now here we have different type of ESPs footprint and their 3D designs available here. So like here I have opened it for ESP32S2. So we have this 3D model of it. The symbol and footprint is here. So with the help of symbol, you can make schematic and assign the footprint to it. So this is the footprint of it. You can simply download this and use them in our KiCad project. So
Okay.
yeah. So the good thing about this website is when you download it, it gives us option that you are downloading it for KiCad, you are downloading it for Altium. So multiple platforms are supported. So it's a good thing about this Snap Magic website.
Okay.
Yeah.
So when we are doing foot at the time, some components not visible in KiCad. So that's why I asked the question.
Yeah. It happens. There is some issues arises when you design your own. So we have to set the path. If we set the path correctly, then it is visible.
We have to upload that file
Yes.
into KiCad.
Yes.
Yes, right?
Yeah.
Thank you.
Later in the course, I can show it to you how we can import custom parts or how we can make our own part or modify it.
Mm-hmm.
Okay, so I hope this is clear to you.
Yeah, thank you.
Guys, any other question on PCB designing workflow? Okay, so if there is no question, let me. Yeah, so you can download this software KiCad from the link. So let me open it. You can download it from here. I will show it to you. KiCad, and if you search KiCad, then we have this option download button, and now you can use your OS. Like if you are in Windows, you can use this, and for Mac you can use Mac, and for Linux same. So you can download it from here. So I suggest you to download it right now if possible, and let's make a simple PCB together. So what do you guys think? Should we make it right now?
Yeah, continue.
Yeah, so I have sent the link, KiCad download link in the chat. So you can download it from there. And I guess, so next is, let's make a simple Flash Light PCB. So should we start or you guys downloading it? Okay, I will show you a simple demonstration. Then you can do the same practice while watching this while watching the recording of this session. So let me start. Okay, so let's open KiCad. Yeah. So this is our main KiCad window. I'm using KiCad 9.0 version. My mouse pointer is visible, right? Hello.
Yes, yes.
Yeah, Hardik is
Yeah. So let me open a new project and let's make a new folder here. Flash Light. Okay, let's create a folder here and let's name it here. We have to put a name of our project here. So let's name it Flash Light. And version name of it, let's name it 0.0.1 and let's save this. So when you click on save, now we have two options here. The first one is flashlight KiCad underscore PCB and another is dot KiCad SCH. So the first one is our PCB file and another one is our schematic file. So as we learned earlier, first we make our schematic. So let's open the schematic file. So this is our schematic drawing sheet. So here we can write our information like the title. Let's write a title, flashlight. And date and revision is, let's write a version name here. And on the company name, let's write PCB Designing Workshop. PCB Designing Class 1. Okay, so let's click on OK. And now you can see we have all the details here. PCB Designing Class 1 and the file name and the title of this project. So let's draw a simple circuit here. So you don't have to fear about these options. You will eventually learn as we make more and more projects. So you got to know about all these icons, what they are doing. So first of all, we have to add symbol of our for our schematic. So you can get those symbols. So you have two ways. Either you can press a shortcut key A on the keyboard, or you can click on this icon, this op-amp icon. So let's press this, and so here we have our all symbols here. So let's write a simple battery. Okay, so let's choose this battery cell and click OK. So on the schematic we have our battery cell symbol, and let's connect a LED. So let's press A for components and let me type LED. So we have this LED symbol. Okay, so we have this LED. Let's choose it, and you can rotate this component by pressing R shortcut key on the keyboard. Now let's add a resistor. Again we press A and we type RESIS. So we have here we have resistor, and let's press OK, and let's rotate it by pressing R. Now let's connect them. So you can connect them by there are two methods. The first one is if you hover around the edge, we have this green symbol which is line symbol. You can click on it, and wiring, it is in now it is in wiring mode. Now you can connect them. another option is if just press X shortcut key. Just press X shortcut key on the keyboard and it is in wiring mode. So yeah, so here is our simple schematic diagram for this flashlight. So now our schematic is complete. So another step is to just compile it and run some DRC. So what is DRC is? DRC is basically design rule check. So it helps us to identify if we make silly mistakes, like if we connect positive to negative. So simple silly mistakes like short circuit, or if we forget to connect anything. So it will give us error and tell us that you should check the schematic first before jumping to PCB. Okay, so let's just compile it. So here we have this ERC symbol, this checkbox icon. So we have to click on it and we will run ERC. So here we have zero warning. But just for experiment, let's just close it and let's just disconnect it and let's see if it will give us error or not. Yes.
Sorry. So we have to put ground symbol, right? It will not showing error.
Sorry.
While doing ERC, we have to put ground symbol, right?
Yeah, you can do. Yeah, you can put a ground symbol there also. But in this case, this is a very simple circuit, so I just directly connect the ground pin of LED to the ground pin of battery. So there is no error in that. You can also put a ground. You can also make the circuit something like so we have power symbols here. You can put like ground. And you can make a copy of it. So this is also fine. You can also make the circuit like this. There is no issue. Generally, for the complex designs, we are using this type of circuits. But this is very simple circuit. That's why we are not using ground symbol here. We are just directly connecting it. So what if we disconnect it and if we run DRC? So most probably it will give us error. Like here it is giving error. Pin not connected. Symbol button pin. The negative passive line is not connected. Warning, unconnected wire endpoints. So here it is giving error and we have some symbols here representing that here we have some error. We have to fix it. So let's just close it and let's connect it again. And let's save this circuit. Control S. And now we will run DRC again. Now we have no errors. So we are good to go and our schematic is completed. Now we can go in PCB. Now we can start make our PCB. So let's go on PCB. Yeah, so this is our PCB making sheet. So here we write here we draw the PCB here. So we can import all the schematic components here. We just draw we have to just update the sheet. So to update that sheet, we go on tools and here we have an option update PCB from schematic. So let's just click on it and let's click on update PCB and let's close it. Okay. I guess there is some error. Errors 3. Okay, so here it is giving some error because it is showing error cannot add no footprint assigned. So we forget to follow the step 3, which is footprint assignment. So let's just assign footprint to all these components. Yeah. To assign footprint, you can go on tools. Hello. Any question? Hello. Yeah. So we forget to assign footprint. That is our step 3. So let's just complete it. So to assign footprint, we have two options. You can go on tools, or we have assign footprint option, or you can do it manually by just clicking to that component. Like this is the we, this is the property panel. You can open by just double clicking on it. So this is the property panel, and here we have footprint option. Let's just click on it. So this is a footprint assignment window. So let's just type battery. So we have different types of battery. Let's use this. Let's use this Keystone battery, and you can see the 3D model of it by clicking it here. So this is the 3D model of it. So let's assign this footprint here. Okay. Okay. So similarly, we can do for this resistor. So let's type resistor. Yeah. So let's assign this resistor. We can see the 3D footprint here. So this is the resistor we are going to use here. So let's click on OK. Okay. So similarly, we can do for LED. Let's assign footprint to this. Let's write LED here. So we are not using SMD. These are different type of footprints like SMD, through hole. So we are using through hole here. So let's see this. Let's use another one. Let's use this red LED. Yeah. So let's use this red LED and click on OK. Now we are done with our footprint assignment. Let's click on save. And now we will import, and hopefully it will work. Update PCB from schematic and update PCB and close. So here we have our all components here. So we just pasted it here, and so this is our LED, and this is our resistor, and this is our battery cell. So now we can just place them, and while placing components, we generally avoid crossing nets. So what is net? So net is this thin line you can see, which just guiding us, like this pad is connected to this pad. So generally we don't want to crisscross them. Like here, these both are crossing. So what we can do is we can just rotate it. So for rotate, we can press on R. Yeah. So now they are not crisscrossing each other. So let's place it accordingly, and yeah. Okay. So we are good to go. We can start routing. To route this trace, we can press X shortcut key on keyboard. Yeah. So we have connected this net. So similarly, we can do with this pad. Just press X, and it is in wiring mode, and click on it. And similarly, so we have connected this circuit. and let's just arrange this. So this is our simple circuit which we just drawn. Now we have to give some boundary or uh, some board layout. So to design that board layout, we have to go. So here we have these different types of layers. So we can go on edge cut layer. So we are on edge cut layer. Now we can draw a shape uh, for our PCB. So let's draw a circular one. Okay. So this is our the board shape, the circular one, and now we can see this PCB in 3D. To see this PCB in 3D, you can go on View, 3D Viewer, and here we go. So this is the PCB we just designed. Yeah. So we can also put some silk screen, some name on it. Let's do it. Okay. To name that, we go on front silk screen and we put a text option, and let's write PCB Designing Class 1. Okay. And so here we can adjust the size of this text. Let's put it around 2 and height 2, and let's bold it. So I guess 2 is little bigger. So let's do it. Let's do it 1.5 and here 1.5 and okay. Okay, so just like this, we can name our, we can put names on our PCB. So let's similarly write a version name. So you can just copy it and change the name of it, V0.0.1. So this is our version name. And okay, so now we will see in the 3D viewer, it will show. Yeah, so this is the first PCB we just designed. So you can practice it, or you can modify this circuit, add a switch in this. So any questions so far? Hello. Hello.
Hardik,
Yeah.
what now you have done?
Sorry.
Good. Just we observe you have done. Good, no questions.
Yeah. So guys, that's all for this session. If you have any question or any doubt, is there any issue, or you are trying to make the same, and if you get stuck somewhere, just let me know.
Yeah. I think anyone having any point, any doubt, just speak out. But I think it's yeah, it's yours only, the session and all. So we are here for you only actually. So if you have any point, any doubt, and the next free demo session will be the next week. Okay.
Love our content? Hit subscribe for more awesome videos. We'll see you in the next one.